in our classroom. Okay. So let me get what I need. Yep. All right, guys, let's take a look at this. Here we go. All right, so Unit 4 is similar to units you may have seen last year if your teacher got to them in the spring. If not, it's totally okay. I'm expecting that there's going to be some parts missing here, okay? But it is talking about measuring data, measuring like information, okay? And as far as like what you'll use in math, or use of math in like business or in any kind of field where you're measuring anything, measuring anything, you're going to need to know how to manipulate and look at data. It's actually something that if you can just understand this unit really well, then you'll understand what's going on in the world much better, because you'll be able to look at data and not be intimidated. You'll be able to look at things like this, right? A box plot, and know right away what it's saying. What's the significance of the different numbers? And you'll probably forget parts of it, but at least you'll be able to, have an idea. You can brush up really quick and know what things are instead of having to learn everything. Because there will be times in your job where you'll have to understand these things in a group, and you might not be the best at it, but you got to know at least what we're talking about. Okay. So the first thing is a dot plot. Dot plots are very basic. It would be, for instance, if if this was in baseball, singles, doubles, and triples, and it was looking at the team on, how many players got singles, 2, how many players got doubles, 3, how many players got triples, 1. Okay, so it's just a matter of looking to see the choices, the options for what could have been accomplished in the data set are options down here, and the number of items in each option is always going to be marked upwards. So then you could see it pretty quick. Okay. Now, histograms are very similar to dot plots, but it is expressing the information in rectangles in area. The area of each rectangle denotes how many people got to first, second, or third base. Okay, so histograms and dot plots we're going to learn in one big swoop. Then we'll look down here at median, and box plot. Okay, so mean, median, and box plot. So let's look at this top part here. I'm going to share, if you do have your workbook, you can turn to page 9. If you do have your workbook, you can turn to page 9. Okay, so when we look at page 9 here, we're looking at dot plots. And we're going to create a dot plot. And what we're going to be able to do is create a dot plot so we can look at all this information that's in the graph, right? Okay, all this information, that's in the table, using a really, efficient way. We can look at all this information as a dot plot, so we don't have to look and see, okay, well, this many people came at this time, this many people. You would be able to look at a graph quickly and know right off the bat, what is important information we need. All right. So this scenario is, a pharmacy is looking at customers who come in during the day, and they have to get their staff to, if you had one staff member or 8 staff members working in the morning, and then during lunchtime you had 1 staff member, that's not going to work because 23 people came in the middle of the day. So they're trying to set up how many staff members they're going to need based on the customer flow. And that's something you totally would do. You would totally do that. If you want to start your own business, you want to do anything, if you're going to be a manager, which is, a good job if you are working more with like, working more in like just, if you work for Amazon, you'd want to work your way up to be the manager, at least, of all the warehouse. And you'd have to be able to do assessment of the needs and bring in the right amount of people to work. Okay, so this stuff's just going to come up. It's just going to come up. We have to have a way to look at information as efficient as possible. So looking at this, we're going to make this into a dot plot. All right, and I want to look to see what is the maximum value that I have here. The maximum value is 23 customers right in the middle of the day. You see? So if I'm expressing this, as a dot plot, looking at our dot plot and what it looks like, a dot plot has, we have to make the dot plot tall enough to account for all the different pieces of data. We have 23 customers coming midday. So when I'm creating my dot plot here, I want to think about, well, Do I need to make, 23 boxes? How tall do I need to make this graph? Because we don't want to end up at the end like going into the other problem. We have to organize it. So what I'm going to say is each of these lines is going to be 2. So I'm going to just count out from here. That's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to go a little bit further. That should get us. Okay. So this is going to be our y-axis. This is the number of customers. Number of customers. Okay. And then I'm going to make some room for my x-axis because the x-axis is going to be, let's see, these are the time frames. Time frames. Okay. And we can even label this, which is custom. We could say number of customers based on time. You see, I've labeled it. So now I'm ready to make my dot plot, and I'll be able to look at this quickly and say, oh, look, that many customers come here. And then there's like a little surge in the evening. Okay. And let's see what we can do here. Let's go ahead and put our time frames down here. So you might have to rotate your graph a little bit. And let's put all the time frames. So look, we have 8 to 9. So I'm going to go 8 to 9. I'm not going to put AM PM because this is going to be fine. 9 to 10, 11 to noon, noon to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 4 to 5, and that's all we got. Okay. And maybe if you want to do that, AM, PM, 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 PM. And obviously, if you were doing like a presentation, you would do this very, very, neat. I probably could have even spaced my time frames out so that they spaced all the way through. That's kind of a little mistake here, but I'm going to keep going. Because I've done all this work, and I would correct that on the next one. So let's look. 8 to 9. Oh yeah, it's a dot plot. Guess what I'm going to do here? I'm going to keep that same scale where I said this was 2, then 4, then 6, then 8, then 10. That's how I counted it, so I want to keep that up. So from 8 to 9, there's 2. It goes up to the first line. From 9 to 10, there's nothing. And then I see that I forgot to do that one. 11 to noon. Yeah, that's bad. This is not my best dot plot of my life. All right, so 10 to 11, there's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's see. It's squished in here, but 11 to 12 is 14. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So don't make perfect dots. We're just doing an example problem here. I'm sure yours look better than mine, actually, because I did not space them well here. But I'm going to keep going. All right, noon to 1, we have 23. That's our big one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I don't know why my voice went higher. I'm just trying to wake you up. All right. So that is our biggest time frame. And then from 1 to 2, we have 12. Let's put that in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So hopefully your dot plot is starting to look like this. And then from 2 to 3, we have 7. 1, 2, 3, 4, 5, 6, 7. And then from 3 to 4, we have 3. 1, 2, 3. And then 4 to 5, we have 5. 1, 2, 3, 4, 5. All right. So that is basically how we're going to create a dot plot. Now, a dot plot has dots. A histogram expresses the same information, but uses rectangles. And there are specific reasons why you would use histogram or dot plot, but right now we just need to know the difference. So this same information could be expressed as a histogram if we were to express it in terms of area, in terms of rectangles. Okay, so if I continued making my rectangles here, in the same height, the same amplitude here of my dots, I would be creating a histogram. Okay, that's the only difference. Histogram uses area, uses rectangles, and dot plots use dots. Magic. All right. So let's see. Let me pull up my group here. Actually, I had you guys hidden. All right, give me a thumbs up, sideways down. Dot plots, histograms. Can we do them? It's just organizing information, right? Thank you for the screen on to show me the thumbs. Good, good. All right, cool. So that is probably the more, the easier option. We're going to have about half of the homework, like the first 5 problems, is going through the steps of doing this. Okay, doing your dot plot, doing your histogram. But the second part of it is looking at our second part. Okay, so let's take a look at what we have now. Okay, I'll say also, when applicable, and you'll know the situations when it's applicable, actually. The scenario will bring it up. But when applicable, always order data from least to greatest. From least to greatest. Okay? Keep that in mind. And then I want to look over some things you guys already know from years past. When you're talking about the mean, you're talking about the average. How do we find the average if we were looking at all the ages of everyone in here? We'd add up all the ages, add up all your items, divide by the number of kids in the class. So you would add up everyone's age, you would divide by, in here we have 17 kids. So you would end up with the average age by adding up all of the item values and then divide by the number of items. Okay, so that's mean. Median is just the middle value of all items in the data. It's the middle value. And if you don't have it ordered from least to greatest, you can't find the median. That's why it's important. Box plot is all about the median. Box plot is like, what's the middle? What's the middle? What's the middle? That's all it ever asks. Box plot has one thing it could say. What's the middle? It's so boring, but we're not going to hold it against it. Box plot just doesn't know anything else in life other than the median. What's in the middle? So let's practice this. The median, middle value of all items in the data. Tell me in the chat, this first example that I'm using my pen right here to show you, what is the median? What is the median? That's easy points. Everybody, give me an idea. Good, Jacqueline. Good, Devin. Good, Jacqueline. Milburn and Ramirez, perfect. Anyone else? Yep. Zinqui, perfect. Dylan, perfect. Yeah, Nelson. Yeah, Lizette. Look, it's lucky. All right, Madera. No need for that question mark. You're right. The median is literally the number in the middle. Median, middle, medium, right? You get a medium pizza. Actually, that's not true because there's small, medium, large, extra large, double extra large. So don't use pizza as your example. But median means like the middle, like the median of a road. It's the middle of the road. But what's different with this one? Somebody let me know. Why, when we're finding the medium of this set of data, why is that different? Why is that harder? This one's easy to see. This one, we have to do one extra step. Why is that one harder? I just need one person to tell me in the chat. Why is that a harder, slightly harder option to find the median here? Yeah. 7? Good. Okay, gotcha. It has an even number of items. So somehow, look, the median is somewhere in between these numbers. Who can tell me, what do you think we're going to use to find the number in between two numbers? It's not the median, actually. What should we do to find the median in this case when we have even number of items? Because it's in between 4 and 5. How can we find it? What do you think? What do you think? Yep, good, Jacqueline. Jacqueline M, got it. Look, we're going to find the average. When you end up having an even number of items, you have to find the average between the two middle items. So watch, I'm going to do 4 plus 5 divided by 2, and I get 4.5. I add together the two items. I find the average by dividing by the number of items. Correct, Victor, yes. The answer is yes. It's going to be a fraction. It's going to be a decimal. It's going to be part way in between 4 and 5, so we're going to end up with a rational number. All right, so now we're down to box plots. And box plot only says one thing. What's in the middle? You like ask him what his favorite TV show is, and it just says, what's in the middle? And you're like, what kind of food do you like to eat, box plot? What's in the middle? It only eats food in the middle. If it goes to like get a soda at like 7-Eleven, it always picks the soda that's just in the middle. Um, it only sits in chairs where it's in the middle, two people just. All right, I'm going too far. All right, box plot is all concerned about what's in the middle. Okay, so just keep that in mind. And there's 6 parts. There's 6 things that we need to find that are parts of the box plot. Okay. Now the easiest part are in our data set. So if we looked here and used this one and just did it real quick for it, right? What is the minimum value? That goes over here on the left. It's denoted outside the box. It shows us the lower limit. The lower limit for this, 2, right? What is the maximum value? 11, right? What is the median, which we call Q2, quartile 2, which is the 50% mark, right in the middle, okay? It's like if this is 0, this is 1 quarter, 2 quarters, 3 quarters, full dollar, okay? Q2 is 2 quarters, it's right in the middle. So if I was looking here and I wanted to know the median, it would be the number in the middle, okay? Then I would look, actually let's stop there. I'm not gonna use this example any further. It gets more confusing if I do. But to find Q1, you basically say, well, we found the median. What's in the middle? That's all he asks. That's Q2. That's the median. And then I look at the lower half of stuff, and he just asks the same thing. It's so boring. What's in the middle? That's Q1. Then I look at the upper half, and it says, what's in the middle? It's Q3. Okay? That gets us all 5 of these parts. The interquartile range is just saying how far is it between Q1 and Q3. And that's simple. We just subtract it. Okay? So that's the breakdown of this. We're going to do an example problem. I need you to be ready to do a little bit of work with this. And I need you guys to answer in the chat on certain parts of this, okay? And those parts are coming up right now. This is on page, I think it's like page 9 or page 10 on your workbook, if you have your workbook. I don't think anyone does yet. All right, look. Example 3. Website Rate My Phone conducts reviews of smartphones. One aspect of the phone that's tested is battery life. Obviously, right? You need good battery life. I have a friend, Joel. Man, his phone dies like 5 times a week. I think he's actually like less successful in life because his phone doesn't work. So try to get a good phone once you get a job. He has a good job. I don't know what his problem is. All right. Sorry, Joel. All right, one aspect of the phone that is tested is battery life. The minutes of battery life for the lowest or the newest 25 phones is recorded in the following table. Draw a box plot to represent the data. All right, there's some phones here that don't last very long. Why is it, somebody tell me now, this is my first question. Why is it hard to find the median, to find the least and the greatest? What would make it easier with this data? What would make it easier to find the least and the greatest and the middle? What can we do to this data? Because I think this is a situation where it's applicable to do this one thing. Perfect, Jacqueline. Jacqueline R. Nice. Order from least to greatest. They need to be ordered from least to greatest. Good, Victor. You guys are right. So don't start writing them out because look what they did for us. Oh, thank you. They ordered it from least to greatest. And I almost put this paper in right. Okay? So, you know what? I might be able to just write it right here. It's perfect. All right. Everybody, go ahead and make a box plot. It's pretty simple. You make a rectangle. You put a line in the middle. You make a whisker. Make another whisker. They just call them box and whisker plots. Maybe you've heard of it, box whisker plot. That's really what we're doing. And then we want to keep in mind what we need to be looking for. So I'm going to keep referring to this page. Okay. So first off, let's look for the minimum and the maximum value. Those are always the easiest to find, the minimum and the maximum value. So the minimum value, I look here, because they've ordered it from least to greatest, guess what? We're in business. Look, $250. There's a phone here that works 4 hours and change, and then you're done. And that's like if you don't even touch your phone. All right, so look, $250 is my minimum. Okay, I'm gonna call that phone U. Let's label the phone so we can keep track. All right, and then the phone that lasts the longest, that's actually pretty good. That thing lasts like 12 hours and 10 minutes. It's phone W. Have you ever thought of that? How it's weird that this letter is called U and that's double U? It's like, it's weird, right? The names of letters are weird. All right, look, we have the minimum, we have the maximum, and then our friend Boxplot is obsessed with, hey, what's in the middle? What's in the middle? So we have to figure out what's in the middle. Let's see how many data points we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 total. 25 total. So I'm going to show you a way to figure this out, but I want the clever ones to tell me, how will I know which one is the very middle if we have 25? It's odd, so we know there is one that's actually in the middle. But if I'm looking at 25 data points, what is the very middle data point? What number is it? Is it number 7? No. Is it number 22? No. Devin, good. Anyone else want to take a guess? Which is the middle data point? Yep, you got it, Lizette. You got it, Victor. You got it, Dylan. All right, you guys are getting it. It's a very lucky number. Friday the 13th. All right, look. The way that you can figure this out, I know that there are 25 total data points. So if I go in 12 from the left and I go in 12 from the, from the low, 12 in from the high, we end up with our value in the middle, which ends up being D. It ends up being 390. All right. So look, we have 3 of our 6 things here. We got to now find, so we call this Q2, it's our median. This is Q1, that's the first quarter. This is Q3, that's the third quarter. Think of it like quarters, right? 4 quarters is $1. So you're talking about a quarter of the way, a quarter of the way, a quarter of the way, all the way. Now, we need to figure out what Q1 is. Let me remind you. Q1 is the median value of the lower half. Okay? The median value of the lower half. So if I'm looking here, though, the one thing I want to be careful with, you don't count the median. You don't count Q2 in your tally of what is included in the lower half. The lower half can't include D, can't include our 390, because if we include D in the lower half, we would also include it in the upper half, and then we have like this overlapping situation, and we're not actually finding, what Boxplot is obsessed with, this what's in the middle. So when we're trying to figure out Q1, we don't include 390. We just look at the first 12 items. I'm going to let somebody go ahead and take a guess here. What is the value going to be for the median? Remember, Boxplot's like, what's in the middle? All right, fine. Hey, what's in the middle? We got to find what's in the middle here of our first 12. Go ahead and look at the first 12 items, which is going to be between U and A. Between U and A, there's 12, so we're going to have to do some special mean. We're going to have to give mean. So think about that. I want you to try to get it on your own. Tell me, what is Q1? Or you can just say the letter of the smartphone. Or actually, you won't be able to do the letter of the smartphone. Just what is Q1? Because we have an even number. Nice, Victor. Nice, Devin. Anyone else? How do you find it? Well, here's the thing, though. Look, Y is 1, 2, 3, 4, 5, 6, right? If I count up from A, 1, 2, 3, 4, 5, 6. So actually, it looks like it's going to be not Y, but what? And it's not going to be an actual smartphone because we're kind of in between smartphones. Not quite. 130 isn't on it. 130 isn't a value we have. All right. So look, we are finding the bottom half, which is between U and A. We don't count D because that was the median. We go between U and A. If I'm looking here, I want to see that there's 12 items. So I'm going to go up 6. I'm going to go up 6. And it's between Y and H. It's right between Y and H. That would be my median for the lower half. I look to see what Y and H are. It's 320 and 330. Perfect, Dylan. Between 320 and 330, you could find the average, or you could see that that's 10 difference. So we're going to go 5 in between here. Or you can find the average. You could do 320 plus 330 divided by 2. And you get, good, Lizette, that's it. You get 325. It's not an actual phone. Good, Madera. It's not an actual phone. It's a value. Remember that sometimes these quartiles end up between our values, so we have to find the average between them. All right. Let's do that same thing for the right side. I'm going to use these 12 because D was the median. What's in the middle? Box plot is now obsessed with what is in the middle of the upper half. So we're going to look between G and W. Between G and W. What is the middle value? How I got 12? Okay, let me stop for a second. There are 25 total phones involved. D is our median. So in order to look for Q1, I needed to look at the lower half. So there are 12 phones in the lower half between A and U. There's 12 phones. So that helped me figure out the middle phone, or the middle is going to be 6 in from each of the edges. Tell me if that helped you a little bit. I want to make sure you got that. Okay. This isn't like a number. We're not finding the number in there. This is just the number of items. So it helps me know, okay, if this is 12, I want to find Q1. It's going to be in 6, right? And then we found the average of that. All right, I see Victor and Isabel have a good number in here. Okay, let's count. All right. Let's count. So look, we're going between G and W. It's 12 items between G and W. So I'm going to go down 6. 1, 2, 3, 4, 5, 6. I'm going to go up 6. 1, 2, 3, 4, 5, 6. So E and F are 6 from this direction, 6 from this direction. So the very middle is in between E and F. So anyone want to refine their guess? In between E and F? Good, Isabel. Good, Madera. Good, Lizette. You got it. All right. So look, it's going to be between E and F. That's 520. That's 520. So the average between them is 520. Oh, let's see how many parts we got, because remember, we only have 6 parts. We got 1 part. We got 2. We got 3. We got 4. We got 5. What was the last part? Interquartile range. All that's saying is, how big is this box? How many points or what is the value total between Q1 and Q3? And the way we find that is just by subtracting them. We just subtract them. So if I'm just saying, okay, this is 325, that's 520. How far is it between it? That is our IQR. Interquartile range. It's the range of numbers between Q1 and Q3. So we're going to go Q3, 520, minus Q1, 325. And we'll do a little bit of borrowing. We'll get down to 195. We got our 6 things. Box plot knows what's in the middle of everything. I don't know their gender. They finally stop asking what's in the middle. Excellent. Could be like, all right, box plot, we're done with you. And we are done with that. All right, guys, give me a thumbs up, sideways down. I mean, as long as you keep asking what's in the middle and you're careful, then these go probably pretty quick. All right, that's good. We got about 7 thumbs. Good. 8 thumbs, 9 thumbs. Jaylene, how do you feel about it? 2 thumbs. That's a thumb. Okay. All right, thank you. We got like 15 thumbs up. So that is pretty good out of 17 kids. So I'm going to go ahead and give you a chance to take a screenshot of this problem, which, remember, this problem is basically just box plot and this example. So go ahead and take a screenshot if you need it. That is that's it for box plot. I feel like it looks like it's more than it is, but we just got to remember box plot is obsessed. They're like, what's in the middle? What's in the middle? And you just keep asking that. What's the big or the lower, the upper? What's in the middle? Okay, then look at the lower half. Hey, what's in the middle? Upper half. What's in the middle? How big was it between Q1, Q3? That's not a what's in the middle question. They have one different question they ask. How far was it between the two middles? That's what they're asking. Crazy. All right, I'm going to go ahead and stop the video.